Yeah. So, appropriate music, I hope, for an appropriate theme for discussing the security of ICS Lab. I'm William Middleton, and that's what I'm going to talk about today. Before I get into it, though, I would like to give a shout out to the Ulla and his crew in the back there, who put up with my Prezi needs and my kind of oddball introduction music. So could we just give a short round of applause to those guys there in the back? Did a great job. Yeah, so today I'm going to talk about a little about what the lab means for my group of Siemens, and then get into some of the challenges in running a busy lab, followed by the challenges of managing the lab in the Siemens secure way. And then I'll finish up with how we tackled some of those challenges in using a holistic drink approach. So, the lab for my division is a critical resource. There's really nothing more important in our relationship with our customers than the lab itself. I think most of my colleagues would agree with me in this. It provides a development platform, of course, and the testing platform for anything that we send offshore. It's also a critical facility for training, both operators as well as young engineers and old engineers learning new things, and then customer automation resources as well. In addition, the lab provides us the ability and the facility to test, implement, and refine actual security procedures. And this is critical. This has been talked about for the past couple of days in several ways, both in terms of hardening and also the notion of hunting. And this is where we can train our people to do this in a relatively safe environment. So I guess the great divide in a typical lab involves then the customer resources and I hope I'm doing that on the right side, and the access resources. The customer resources are the ones that are configured with the customer's config and which duplicate or even replicate the offshore configuration, and then the access resources are the ones that we use to get into those, and they're typically separated via some sort of a network. Naturally, it goes without saying that it's a bad idea to blend these together. So the number one job in securing any lab, in my opinion, is to make sure that your access resources are safely and cleanly separated from the customer config. Business interests then drive most of the security considerations for the lab. Business is a code word, actually, for management and sales and marketing and everybody else who's trying to make our companies profitable. And so their demands, their requirements, they introduce a lot of challenges, security challenges to the lab, and I'm going to talk about those now. One of the biggest ones, of course, is the notion of concurrent development. You'll find a couple of questions from me. I didn't have many, but concurrent development, at least in our lab on the west coast of Norway, involves having our customers deploy multiple copies of their offshore system in simultaneous project development, which all goes more or less at the same time with different groups of engineers. This introduces technical challenges to the lab, and in particular, one of the most significant ones is duplicate networks. So I'm going to try to show you today how to make that challenge a little bit easier. Management would also very much like for us to be able to share and properly delegate expensive level 1 resources between and among the test areas. These are pretty critical resources, and they're the thing that generally costs the most in any given lab deployment. Management business has a number of other priorities which can't be overlooked. These include 24/7 uptime, of course, and then also the ability to cleanly and nicely do multi-site collaboration. So we have developers in India, for example, accessing our lab resources, working on various components of the HMI upgrades, for example, while we're sleeping back in Norway. So to help me keep track of all of the management and business priorities, I developed a simple, handy reference tool, and I'd like to introduce that to you now. This, my friends, this is the ASS triangle. Yes, you may have heard about this. It provides a simple way for us to prioritize things that are important to management in the lab, starting with availability and, of course, simplicity, and then don't forget, well, security. And while that particular innovation was perhaps the most widely retweeted and discussed innovation from my talk at S4, I felt like I needed to provide a bit more detail. So I'm going to talk about the other priorities in the lab. Excuse me, a little bit dry. This morning I should have brought a bottle of water. These priorities are introduced by the automation engineers themselves. And these fine folks have the toughest requirements for us network folk and IT folk in the lab. In fact, they introduce the most challenging security requirements of all, which is to say, occasionally none. But they have to be able to simulate the process accurately, demonstrate, that is to say, prove that the process is properly controlled by the HMI innovations which are being developed in the lab. And this goes, all the way down to the individual signal interchanges between the different components. And then when they're done and have commissioned offshore, they want to be able to quickly and reliably reconfigure any given lab area with any given new project. So pretty demanding requirements. Thank you, sir. Pretty demanding requirements on the part of the engineers, automation engineers, and we do everything we can to support them. So, hei Norge. Finally, the last, the one that I'm going to talk about, and maybe the most important one for the typical automation engineer, is to eliminate, or at least limit, unknown variables in their test environment. And this requirement, unfortunately, leads to other configurations, albeit temporary, that can introduce additional security risks in the lab. So, before I move on to how we tackle these challenges, I do need to say a little bit about how the security process was achieved in our lab relocation, which is really the fundament of this presentation. Security management in Siemens is a shall we say a complex process. There's many facets, and the ones that I'm going to talk to for this condensed CS3 version of my presentation are assets and asset classification, and then I'll go into the so-called levels of security management, followed by the levers. So first of all, asset classification is, like many other security processes, a life cycle process. So for the industrial control system lab, which is being relocated, that's to say brownfield lab, this mostly involved a review of the existing assets and by upper management, along with a assessment of their new vulnerabilities given the known the new risks given the new known vulnerabilities for these particular components. Once we have the asset classification in hand, we can go on to the selecting the security, the protection level for the lab. Protection levels are a relatively new concept that are being introduced into 62443 with input, if I'm proud to say, from some really, really smart Siemens people. The typical assignment of a protection level to an asset or to a system involves a number of evaluations which have to be performed on that system, and as a rule, these evaluations are performed on the on-site system. That's to say, offshore in our case. So doing this for the lab then meant that we had to treat the lab as the final location. And this is relevant at least for lifecycle management components of the lab that are in fact ongoing and permanent, but maybe not so much for projects. But we did this, and the maturity levels that are part of this evaluation are the most critical thing and probably the most difficult thing to achieve in terms of meeting of attaining the protection level that's specified by this new 62443 component. We did this in our lab, and we are the powers that be, the security officers and the upper management in my company assigned the security level. We evaluated the old lab, and we tried to make the new lab attain these requirements. I'd also like to mention that the maturity levels have a very close analog, in my opinion, to the much discussed security hygiene, which has been rolled around quite a bit lately on the Twitters and the various discussion groups. This seems totally obvious to me that, although not everyone concurs with me, that hygiene and maturity are very closely related, and all you have to do is ask anyone who has teenage boys in the house, and I think you'll find a concurrence there. So, finally, moving on to the holistic levers of the process. Today I'll mostly be discussing the network security, although all of these are of course relevant. And there's plenty more in the Siemens process, but my time constraints today limit my ability to provide these for you and go into detail. So threats. These are the perceived threats that we found in our lab, and I would like to propose that these are common. That's to say that these can be found in most labs, at least most labs that are actually deploying their components offshore or to the production site after they've been FAT tested. One interesting one here is accessing the incorrect copy of the system. This is what I call the concurrency errors, and I'll get more into this a little later. The corresponding risks then involve the loss of or damage to the lab systems, loss or exfiltrated Siemens IP, as well as loss or exfiltrated customer IP, infection spread from one lab area to another, and then, of course, changes to the incorrect copy of the system. However, there's no actual process to lose control of in the lab, right? Well, maybe not. I kind of rambled on in this slide here, but really making a long story short, having customer IP in the lab means that if that is exfiltrated, everything that is about is about the complexity of the control system process being unhackable, or at least very difficult to hack, sort of flies out the window. So exfiltrated customer data, configurations, topologies, multi-projects, basically anything that can give the attacker an insight to the production system is extremely valuable, and arguably introduces other types of risk than just simple monetary loss. Impacts, yeah. Delayed deliveries, of course, penalties, loss of income. I have that first because I'm Siemens. The damaged reputation, though, of course, is very important for us. And then, as I mentioned, environmental damage from the one I just mentioned. Although it would be not a direct threat, arguably it and both of our customers and our local systems are configured to avoid these type of things. It is possible. And then one more that really nobody likes to talk about, but that is, in fact, a possibility. And that's where we send Gumby offshore. And as you can see there, this possibility is, of course, vanishingly small, given our commissioning, given our FAT procedures, given the security operations that we go through as we are packaging and getting things ready for deployment, for sending offshore. But any lab operator, any lab manager worth his salt has to be losing at least a little bit of sleep over this possibility, as well as the one I previously mentioned, exfiltration of customer IP. So, okay. Finally, mitigations. I'm going to kind of gloss over this one because I don't want to go over my time limit here today. And I'll come back to most of these when I discuss the technology coming up. But basically, I'll discuss the network bits today, the NAC and the dynamic VLANs and whatnot. I just won't have time to get into that, but we do implement that in our lab, and when it's appropriate and necessary. So finally, on to the solutions. The solutions I'm going to discuss today are, as I said, mostly network-based. I won't be talking about the actual offshore platform names. I won't be mentioning those, even though they're pretty cool names like Valhall and Marien and whatnot. But I'll be using the more generic test 1, test 2, test 3 definitions today. I'll also be referring to diagrams like this one, which I should have had a zoom here, but basically this is just sort of providing a simple example of a test system in our lab with the appropriate ISA levels and the ICS components hopefully visible and clear. This then is the simple overview of the topology in our lab. You'll see the internal with the independent test systems, and the external with the access components, including terminal servers as well as core services, and then the individual test rooms where we sit with our customers to do FAT in our offices. The outside is where our engineers remotely access the lab from the Siemens Enterprise Network, And then there's that other one there, which I'm not going to get too much into today, but we do actually provide a little bit of customer access to very tightly controlled a network direct into our lab, which is implemented through a point-to-point connection. So today, three network, as I said, my primary focus is on network solution, and therefore I'm going to talk about how we do that. And the first trick is to pre-assign network space to each of the test areas in the lab. We do this by basically allocating externally visible IP space and internally visible VLANs to each test area. The intelligent top of rack or tour in Norwegian devices are the next thing I'll discuss, and these provide the heart and soul of our network technology in the lab. And then finally, I'll go into the network security, which is based upon these two things. So the pre-assigned network space takes the 10 to 12 bits of IP space that's externally visible, that's to say to the access components, and assigns it to each test area. We also give them each as many VLAN IDs, unique VLAN IDs as they need. And then this supports both concurrency and duplication, as well as lets us build our DNS solution upon it, greatly simplifying the access and reducing confusion among the engineers for which test area they're working on a given day. Here you see how it works. The aggregate route is then routed to each test area through a point-to-point connection, and we have you'll see as in a minute, we have a separate connection for the layer 2. Our layer 3 devices, our intelligent tour devices, are, as I said, basically the heart and soul of our lab connection. We looked at a lot of different solutions for how to do this. We knew we needed protection at the edge of every single test area in order to restrict lateral access and what have you. And as it turned out, simple Linux networking gave us all the functionality we needed in one little box. The devices we chose from Ubiquiti are pretty sweet. They let us do layer 2, layer 3, everything that we need from routing and switching, NATing, and of course firewalling on each one of their 5 ports. And one of their ports is even power over Ethernet. So this provides everything we need at the edge, and then all of the NATA traffic is sent down into the customer gear, which of course includes all of the Siemens proprietary gear, including additional firewalls and additional switches where appropriate. These devices also give us some really nice capabilities related to management and monitoring. The Ubiquiti provides this UNMS interface, which is free and which lets our lab manager monitor all of the systems simultaneously in the lab, which are active. And when one goes down, we immediately get an email. So this is really handy, especially when your lab management or your lab manager or your lab operators have little or no budget, as is unfortunately often the case. Again, though, I'm proud to say that my division of Siemens is finally funding these extravagances. So, and there you see. This has been a while back, but there you see that we have a number of these devices in our lab, and in fact, as you'll see later, we need a number of them. But at $50 a pop, they're real easy to get a budget for. So with those things in place, I can finally talk about our network solution itself. Here we come back to the mitigations that I talked about earlier, as well as the customer business goals, which we have and which we hope to meet in this implementation. So I'll discuss these at layer 3 and layer 2 today, just because that's what makes sense to me. And looking right at layer 3 then, as I mentioned, we route the aggregate routes through point-to-point connections from the lab primary firewall down to each test area. And then the lab primary firewall manages the global firewall rules like SMB and the things that you just absolutely should never be doing from the outside to the inside or in between. And then the little top of rack devices manage everything else. The typical connection then involves having a convergence between the rules that are on the primary firewall along with the rules which have been implemented locally on the tour firewall, together with the natting operations that are or the natting rules which are specified there. All together, then if they all match up, then the packet or the connection is sent down to the customer network space. And it seems simple enough, but there's a lot of intelligence there, which is really important and which helps us meet a number of our requirements. So natting is, in fact, one of the fundamental ways that we meet both our security requirements and our business challenges in the lab for concurrency. It protects our customer IP topology, which is never visible from the outside or from the external areas, from the access areas. It also supports concurrent development, as I mentioned. And as I said, it also requires one physical device for each copy of the network that we want to have in the lab. So let's see how that expands a little bit then. The group A, in this case, of the TST platform might be a lifecycle management group. In fact, typically is the lifecycle management group. These guys are the first group in the chain for the concurrent environments that are dedicated to this platform, and therefore they own their top of rack device receives the first route. The second group might be working, say, on an HMI new feature in concurrence with the lifecycle management development activities that are going on all the time. This group would be assigned the B group identifier in the DNS and accessing their engineering station, which is exactly a copy of the test egg engineering station, at least at the beginning of the development cycle, would involve using the B identifier in the DNS. As you can see, their IP is subnetted from the master aggregate route that we assign to the TST platform in general. Finally, that extends to as many devices, as many copies of the environment as you need. Here, the C group takes the what's remaining of the original assignment of the network and nats over to their copy of the system. In this case, this might be, say, a PLC upgrade. Short-term project, but definitely needing to use a copy of the offshore, the actual offshore production environment, and not what is in development by some other group. In each case, the internal network space is exactly the same. And the DNS naming scheme lets the engineer who is bouncing between these development projects always find the right one on any given day and avoid blunders that are associated with accessing the incorrect test environment. And finally, allocate a couple of notes on pre-assignment, allocate enough network space for your environment to suffice for future expansions, and to keep your routing table relatively simple, and then place the busiest areas, of course, closest to the edge where you optimize the bandwidth. So layer 2 is next, and I'm running short. Layer 2 then is where we handle our virtual components and component sharing. This is the typical environment. We have completely virtual environments, completely physical environments, and but most of our environments are hybrids. Okay, the typical lab setup then involves the here you see the color-coded VLANs. The test area 1 is assigned 3 of them, and it the physical devices in test area 1 communicate with the virtual devices over this layer 2 topology. Everything goes through the lab core switch, and the tour devices also very nicely and neatly support 802.1q, so that all the trunking could go right to them as well. In addition, we support component sharing. As I mentioned earlier, this tackles one of our business challenges when we need to share a component that's physically installed in test area 1. We just extend the VLAN from test area 2 over to test area 1, and voila, the component is now visible in test area 2. This is usually, not always, but almost always simpler and safer than pulling the PLC out of the rack and putting it into the rack with the other development group. It also avoids yet another cable hanging over the top of the racks. So the layer 2 also lets us nicely do things like spanning and network monitoring, and again back to active defense and training of our security staff. So, summing up, the white text is the things that I managed to get talked about today. You can refer back to these in the slides. The orange text are the things, yellow, orange, is the ones that I would have liked to talk about but had no time to do so. And these include, of course, and the one I would like to emphasize is to be sure to update and manage your access resources, your external, separately from your internal. That's to say, keep your access resources patched and up to date at all times, no matter what your customers want to do with their internal components. Basically, nothing too complicated here, but putting it all together, I think we did manage to tackle the fundamental challenges we had in our lab, and that's about all I had to say. I thank you for your attention. Oh, look for security solutions, always, that increase productivity.
Well, thank you very much, William.
Thank you.
Interesting talk, very interesting talk. Here's a small gift of appreciation from us. And of course, you have a number of questions.
Oh,
so
good.
If you ready to answer them?
I will try.
Okay, all right. So, do you apply security monitoring within the lab network?
Of course, yes. We have both syslog and Windows logging that we extract to a common area, and then the app ID functionality of our chosen primary firewall also lets us keep pretty close track on what's going on from the external to the internal. This is our primary concern. What's going on inside the test areas is it less of a concern unless we specifically need to do debugging or some kind of monitoring there typically related to bug or problem, but can also be related to, for example, security research, where we would very much like to extract a PCAP of the entire FAT process, which captures both the HMI and the lower level networking in one single, easy to study and easy to research tool.
All right. Thank you. Were you worried about security of your ubiquity edge devices given their spotty history with vulnerabilities and patches? Or how did you approach your supply chain risk for your build in general?
For our build.
Build.
Well, the ubiquity devices are, I think they've gotten a bit of a bad rap, but I mean, you know, being from Siemens, I know this problem pretty well. We keep them patched, of course, and they're dynamically updated through the UNMS interface, which I showed you. This makes it extremely simple to keep up with problems that show themselves. And I mean, it is, as I have said, there are significant risks in the lab, but there are related to external access. We are not, our lab and our external firewalls are not the last link in the chain either. We are being very carefully watched by our overlords in Siemens IT, of course.
Okay, I can imagine. What is your experience with virtualization of level 1 devices for lab work?
Well, there you might be going a little over my head. I'm mostly a networking guy and IT, okay? I know that, I mean, we have simulators, obviously. Most of the simulators that we currently use related to our PCS7 deployments are, in fact, physical devices, but there are these cutting-edge automation folk that are, in fact, putting these into a simulator. Servers, even the older serial protocols can be simulated now in a virtual environment. The stopper, kind of the showstopper there is typically the network interface, where we have our proprietary protocols that are built into our NICs, so that S7 and ISO are independent of TCP. This by itself also enhances security, arguably, but does require then a physical realm for at least some of our components.
Yeah, I was wondering, you've been talking about the networks. Do you exchange data in another way, like USB sticks, or?
We have, I have, in my S4 presentation, I had a long spiel about USB. I went over time there, and it was, and didn't have time to answer questions, so I had to nix that for here, because it seemed like most of you are already doing USB protection. The answer to getting rid of USB, obviously, is to provide a real good, well-engineered network transfer solution, either direct through your RDP connection or SFTP or some way from the external, or in addition to having some sort of a local device, which I'm looking at very anxiously. Our host, Robert Malmgren, has a very interesting product that I saw at the expo, which basically lets us then transfer files from, in a safe way, from an engineer's USB, which they'll always tell you is perfectly clean, into the lab environment.
Right. So do you have another mechanism to try to detect if that content that is moved into the test environment is clean itself?
Well, our network transfers are, of course, scanned as they go through, as they come in, as well as once they land on the file system, they're scanned again. And then when they're transferred over to the particular test system, then the local test system scanning, which is typically required by the customer. So this is typically customer software that we deploy in the lab. It scans it one more time before it's finally taken into use.
And that is typically AV software that scans it for malicious.
It's AV software at the customer layer. The customers also implement a number of other things that I could tell you, but then, you know.
Okay, they have to kill you? Oh, yeah. I'm sorry about that. Don't do that. All right, moving on. What should Security ICS R&D lab consist of? How to approach software hardware reverse engineering from a legal aspect and multi-vendor bug hunting?
Well, I don't. Excuse me. I don't have a hacking lab. I don't manage one. I really don't understand what that means. The one that you had here, obviously, is wide open, and that's the design. But that's pretty much a foreign concept to me. So, as I mentioned, though, training our security engineers, training our automation engineers to be security conscious is something that we focus on in our lab. And in doing so, we plan patching. Of course, every single patch that goes into the offshore system has to be tested in the lab, especially for our older legacy systems that don't have direct support from Siemens anymore.
Right.
So there's a lot to be said there, but I don't have a hack lab. So I'm not sure I can really address that.
No, but you will get the chance in this next question, or there's multiple questions actually. So we'll start with the first one. What is the main purpose of the lab you're presenting? It's not a security lab, so this.
No, that's correct. This is a production lab. So this is all about keeping the customer happy with this lab. Okay, you know, as I mentioned in the beginning, our customers have offshore platforms with myriad processes. You know, this isn't just water treatment, folks. This is a whole bunch of different things going on at the same time, and they're always optimizing, always refining and upgrading the various components of this process, all the way down at the field device level, and then all the way up. And these changes then introduce additional changes all the way up to the HMI and even out for the IMS data. So that's what we're about in my lab is keeping the customer happy. And as I said, it's the cornerstone of our customer relationship. We keep them really happy.
Okay. Next question in this multi-question question. Which equipment are you testing?
All of our solutions, and I work for PD Solutions in Norway, formerly, are based on PCS7 controllers. So that's basically the one that we deploy and test and develop and upgrade in an ongoing process. The newest ones, PCS7 version 9, is coming later this year, and but we have systems going pretty far back. So, but it's mostly dedicated to that.
Okay. Mm-hmm. And someone the same person is wondering how big this lab is. I don't know if it's in terms of physical space or a number of test systems concurrent.
How much can I say about that?
Yeah.
We have.
It's huge.
It's bigger than a bread box.
All right.
We have 64 individual full height 19-inch racks in our lab. And this supports more than half a dozen large offshore platforms on the western coast of Norway, as well as a number of smaller installations, rigs, and even some offshore refinery production.
Okay, that's a good question. Oh, good answer, sorry. Is it part of every Siemens product lifecycle? And I guess that you just answered that. It's not for all the different products that Siemens have, but for the one PCS7, for example.
The Siemens product lifecycle is what I tried to address at the beginning. Siemens is of course focused on delivering updated products and new solutions and new technology to the market. Unfortunately, well, I wouldn't say unfortunately, but not all of our customers are ready to go in that direction immediately after their release. So we are therefore happy to support all of the older versions which are available, and most of our platforms are in fact right now hybrids. That's to say, we've got the older, we mix the older teleperm serial solutions together with PCS7 solutions, and they are slowly but surely upgrading these to PCS7.
All right. Having info on client facilities and setups in your lab, doesn't it make you and the lab a prime target for nation-state actors? As I mentioned, there is a significant risk related to lab
and to managing a lab, which I don't think I pointed out well enough in the previous version of this presentation, which I gave at S4. I kind of cracked wise a little bit there and regretted it afterwards, because this is a very serious concern, in fact. Unfortunately, it isn't always recognized by the business interests or even the automation engineers, which are utilizing these facilities to deliver solutions on a very tight schedule. So the answer, short answer, long, yes, it's a very critical system and needs to be thought about and evangelized even at a level that makes us all aware of the importance of it.
Okay, thank you very much. I think that concludes this session. Thank you so much.
Thank you.